everyone, I am Dr. Likha Chandran, working as an assistant professor and teaching chemistry from the Department of Science and Humanities at MLR Institute of Technology. I hope everyone remembering the previous classes which we dealt about the polymers, like what are the different types of polymers, classification of polymers, and how a polymer can be made, different polymerization techniques, everything, especially the mechanism, addition mechanism of the polymerizations. Today in this class, we will be dealing about the plastics. So basically, we can say that all plastics are polymers, but all polymers are not plastics. So in today's presentation or the class, I will be dealing with the introduction of plastics. What are the different constituents for making a plastic and what type of classification we can do with the plastics. So basically, the word plastic comes from plasticose. That means, plasticose means being shaped or molded. Okay, plasticose, that means being shaped or molded, which can be shaped or molded. So we can say that plastics are high molecular weight organic materials which can be molded into any shapes by the application of heat and pressure, and which has to be done in presence of a catalyst, because without the use of catalyst, this, even if we are applying heat and pressure, the reaction will be very slow. So it will be taking time. So catalysts are used because so that the reaction becomes faster. And also these plastics are, we can say that it can be referred to as a malleable nature. That means very clearly which can be made into thin sheets. Okay, the material which can be made into thin sheet by applying any pressure, or extrusion. Extrusion means the process by which the polymers have been manufactured by the preparation method, and into some films, fibers, plates, tubes, bottles, any such shapes it can be made. So a plastic material generally should have sufficient rigidity. Rigidity means hardness, then dimensional stability. That means in any dimension 1, 0 or 2 or any way, if it is folded, molded or any stretched, it should not break. That is dimensional stability. Mechanical stability, that means even under high mechanical stress or strain, that material has to withstand. That is, when we are applying some pressure onto it, it should not break. That is the condition. At room temperature, to serve as useful, so that we can use these materials, or the material can be used as a useful article, gadgets or structural parts. That a material which is having all these properties like sufficient rigidity, dimensional stability, mechanical stability at a room temperature, then these materials are known as plastics, or we can manufacture such materials and to some useful articles, gadgets or structural parts. Now, what are the different constituents of plastic? What materials should be added along with a polymer to make it as a plastic? That are, we have to add resins, plasticizers, fillers, then lubricants, then stabilizers. After that, we have to give pigments, antioxidants as well as catalyst or accelerators. So these are the different constituents of a plastic. So a plastic should contain resins, plasticizer, filler, lubricants, stabilizer, pigments, antioxidant as well as an catalyst or accelerator. Now let us see each one by one. Now what do you mean by a resin? So resins are basic binding material which hold the constituents together. That is, if a plastic material is having this bonding, C, everything, okay, hydrocarbon bonding. So some material has to be bonded or added along with this one monomer and the other monomer, so that it binds together. That bonding should be very strong. That material is known as resin. So they will be having linear polymers with low molecular weight to enhance fusibility. Fusibility means it can give fusion, or it can change into desired shapes. If we break this will be another particle, this will be another. So this fusion should be very easy. It is then converted into cross-linked form during molding in the presence of a catalyst. So what happens when we are breaking this or when we are changing this, that is generally linear polymers, when we are breaking this or fusing this, what will happen? This will become another monomer or polymer, and this type will be another polymer, so that it can be converted into different shapes. So what is happening now? We can get like thermoplastic resins and thermosetting resins can be taken as an example. Now comes plasticizer. What is plasticizer? When a material has to be plastic, or when it is called to be as plastic, when it is having the plasticity nature, that is elasticity nature. So how we can improve the elasticity? They improve the elasticity or elastic nature by the flow of processing by reducing the intermolecular force of attraction. When the molecule like HOH, when this bond is very weak, then it can have a very flow like water, right? So if this bond is very weak, this will be more viscous, or it can flow more fastly. So when this intermolecular force of attraction is weak, the molecule can have a plastic nature or can have increased plasticity. So for that we use like many organic phosphates, oleate, or dioctyl phthalate. All these materials can be used as a plasticizer. Now comes fillers. What do you mean by filler? Filler, from the name itself we can understand, right? Something has to be added so that it does not feel like, or the material does not feel like empty. It should be filled. In that case, the filler will be like which can increase the tensile and compressive strength. Tensile means if a stress is applied or strain is applied, if there is a material, like if we say that a polyethylene cover is there, and if we are applying some amount of stress to it, a very high amount of load is given, what will happen? This at a particular stage it will start breaking. So when this breaking is not there, or if we can increase this point so that it does not break, that is known as tensility or tensile strength. And compressive strength, when the material is compressed completely, that is when it is completely pressed, or so that it will give to another shape. So it has to be, the material should be like, the plastic should be like, it should not be compressive, or it should not have less tensility. High tensility should be there. So such materials which will make the polymer feel that the material is filled with anything, and we cannot do any compression, or we cannot reduce the breakability or tensility of that. So that is known as fillers. This material increases the tensile nature and compressive strength of the material. They also reduce the shrinkage during setting of plastics. What happens? Some material, if there is a void inside it, we can see that it will get shrinked. On that part will not be having empty bottle if we take, okay, and if we blow air into it, what will happen? Some part it will be having continuous. If not, if a squeezed bottle, if we give air, what will happen? It will come back into its normal place, normal shape. So that is known as shrinking effect. That is when it if something should be inside the box or material, so that it comes back into the same structure. So shrinkage during the plastic should be less. For that we can use mica, quartz, limestone, acrylics, etc. Now comes lubricants. What are lubricants? Exactly, the lubricant means which reduces the friction. So why lubricants is needed? We are joining two different particles, two different monomers. So what happens? The friction will be very high. So when it is very high, the particle will not be able to move among each other. For that we have to reduce the friction, and so that the movement of the particle will be easy. As well as when we apply lubricant, the shape or the structure of the material will be very shiny. So in order to that also lubricant is added. So for that we will have use waxes, oils, soaps, etc. Now comes stabilizer. From the name it is very clear, stabilizer means which can induce or increase the stability of the material. So such materials should be added which can increase the stability of the polymer during the processing itself, during the making itself. So stability means thermal stability. We can see that plastic material, when it is heated, it will get more demolded, right? Its shapes will be changed. So that should not be there. So it should has to withstand the temperature, high temperature. So stabilizers are used to increase the thermal stability during the processing itself. So we can use some like stearates of lead, barium, cadmium, etc. This material will be having high stability. So when we add a light amount of this to the polymer during the preparation itself, then stability will also be increased. Now comes the pigments. Pigments, as we all knew, pigments means which gives color to the plastic, right? Which will give color. So we can see that different plastic material in our home itself will be having different colors. So these colors are being obtained from the adding of pigments. For example, ZNO or titanium oxide, zinc oxide or titanium oxide will give white color. Green color material is obtained because of chromium. Okay, then black is because of carbon black, red lead is because of red. So all these colors will be giving all these materials will give the different colors to the plastic, and else antioxidants, like they will protect the plastic material from the oxidative degradation. Some materials we know, like normally if we say like Ag, silver, if it is kept in oxygen or in presence of oxygen for a long time, it will get oxidized. So somewhere we have to add some antioxidant to it. In the same way, for a plastic, when we have to prepare, we have to add a little amount of antioxidant so that it will not undergo any oxidative degradation. For example, we have to use phenyl paranaphthylamine or diphenyl diamine. Now last but not the least, it comes catalyst. Now what are catalyst? Catalyst, obviously, which will accelerate the polymerization reaction. That means which will increase the rate of reaction of polymers, so that what happens, the reaction happens very fastly. We knew few catalysts when we dealt with the addition mechanism. I hope you remember the class. It was like benzoyl peroxide and hydrogen peroxide. What will happen? It will, when a light or a heat is obtained, this will break into two different initiators, right? Same thing we can use for, because it is having high energy or radical formation is very fast. So reactivity will be very high. So these materials can be used as catalyst. So the different constituents, I will go back to the slide once again and I will let you know what are the different constituents. The different constituents were resins, plasticizers, fillers, lubricants, stabilizer, pigments, antioxidant as well as catalyst. Now comes how a plastic can be classified. So basically the plastic can be classified into two different types, like thermosetting as well as thermoplastic, and this classification is based on the intermolecular force of attraction. Now what is intermolecular force? We can see that it is an HCl compound, right? HCl. What is happening? H is bonding with Cl as well as H is bonding with Cl. So this bond, when it is together, the HCl, it is having a strong covalent bond, whereas two different molecules, the bond between the two are very weak. It is having a weak, that is intermolecular force of attraction. Same in case of water, HOH. So what is happening? This HOH, this H and hydrogen and oxygen will be having a strong intermolecular force, whereas one more another, if HOH is coming, this will be having weak. This bond will be very weak. This will be weak and this will be strong. So that is known as intermolecular force of attraction. The molecular force of attraction or the bond force of attraction within the molecule and with another molecule is different. So what happens when it is strong? When it is within the molecule, it will be having a strong covalent molecule. When it is with another, then it will be having a weak intermolecular force of attraction. So on basis of intermolecular force of attraction, two types we can classify plastics, that are thermosetting as well as thermoplastics. And they are like, what is thermosetting? When it is having molecular waves of, so we can use this material for the, when it is like strong molecular force, right? So these materials can be used for the plug points, sockets, everywhere. And thermoplastic, normally used, which can be remolded or rechanged into desired shapes. Normal household items, toys, everything will be using of thermoplastics. Now, what are the major comparison, or how can we differentiate thermoplastic and thermoset plastics? So thermoplastics, the resins become soft on heating and rigid on cooling. What is thermoplastic? We can make into different shapes accordingly. What happens when it is heated? I'll give you another example, like carbon. All different molecules, okay, like all different polymer chain. What is happening when we are applying heat to this? This starts breaking. These bonds will be breaking. So what will happen once it is breaking or broken? We can mold into different shapes. This will be like, if it is as in having a linear shape, now we can change into 3D or we can change into different shape. This material, what if it was having a vessel, a shape of square, now after heating, this resin starts breaking. So what we can do, we can change into a circle. So according to that, each time we can change into different shapes. What about thermosets? Once it is set, it is already set. We cannot change in any other conditions. Now, thermoplastic is formed by addition or chain polymerizations only. Whereas thermoset, it will be formed by step or condensation. Sometimes it can happen through the addition polymerization also. It is not necessary that always it will be condensation. Sometimes addition as well as condensation it can happen. But in thermoplastic, it can happen only by addition polymerizations. Then next, the thermoplastic will be, obviously, if it is addition polymerization happening, then it will be like completely with the polymer or linear polymer chains, completely a linear chain will be formed. Whereas in thermoset, what will happen, since it is step, it will be having various steps like structure here. So it will be giving a 3-dimensional structure to the polymers. So one will be with complete linear chain, the other one, thermoset, will be 3D structure. So thermosetting, whether we heat or cool, the chemical nature will not change off. But in thermosets, once it is like heated, it is permanently heated, that we cannot set the resins again and again. Thermoplastic, since we can remold it, it can be reshaped, but thermoset, it cannot be reshaped. Thermoplastic, obviously, we can claim it from the waste materials, but thermoset, we cannot do, or we cannot claim it back from the waste materials. Thermoplastic, what happens is, any organic solvents if we add, that will get dissolved. For example, PVC, if we are adding it in acid, what will happen? It will completely break. Or polyethylene, a cover, when it is dipped in an acid, it will completely break. But this material, thermoset, whatever it is, like electrical sockets, right? Our plug sockets are there, no? That plug sockets, even if we dissolve in acid or put it into acid, it will not get break. Or our nylon rope, that also when we add into acid, it will not get break. So these are not examples also, and what is happening is like along with the solvents I told. So what happens, because it is not getting soluble in the organic solvent, because it is step polymerization happening, right? So this bonding will be very strong between each molecule. So it is difficult to break. Whereas here in the thermoplastic, what is happening? It is like chain polymerization. When we give a light amount of heat itself, it will start breaking. So it is like, if it is very easily breaking, then it can be dissolved in any solvents. That's all. So for today's class, I dealt with plastic, then the constituents of plastics, what were the different constituents happening, then the different, what were the classification. So I hope everyone understood the basic concepts of plastics, different constituents of plastics, as well as the classification of plastic. For the next class, we will be dealing with the different plastic, like one example of thermoset and one other example of thermoplastics, like PVC as well as bakelite. Thank you.